Thanks to everybody who's here. We're excited to have everybody. This is a continuation of the webinar series we've been running for a little while now, and I know a lot of folks that we work with or work with school districts. So we hope everybody enjoyed their summer and had a great summer and has hit the ground running without any major incidents. We know this can be a challenge, and that's why we exist, to help try to prevent those things. But really excited to have on two of the people I get the great pleasure to work with all the time, Tracy Lyle and Hilmi Turan. So Tracy's from Aerowave and Hilmi's from SEMA Wireless. If we can kind of go through a couple of introductions. Tracy, if you could introduce yourself, and then Hilmi, if you wouldn't mind as well.
Sure. I am Tracy Lyle, graduated from Texas Tech. I won't give you the year. And spent many years in sales and sales management, and have been with Aerowave. This is my 21st year, I guess.
Happy 21st birthday. Here we go.
Thank you.
And Hilmi?
Yes, my name is Hilmi Turan, and I'm the president of SEMA Wireless. I'm an electrical engineer by trade, graduated in 1997 from Istanbul Technical University. Worked in so many big companies like AT&T, Ericsson, T-Mobile, before I decided to start my company in 2013. And first, I focused on cellular network in my early years. Those were the golden years for cellular network, the late 90s. Then people realized that the towers are great, but they can't talk inside of the building. So we started doing indoor networks. And then I started my company, and I continued to design and install these systems. Then in 2015, I started doing emergency responder radio coverage DAS systems, which are not too different from cellular DAS. This year, we reached 500 systems completed as SEMA Wireless, cellular and ERRC DAS systems. And we've been partnered with Aerowave for a long time. We did a bunch of ISDs and other private and government buildings together. And we have a very strong relationship with Aerowave.
Yeah, well, thank you, Hilmi and Tracy, for introducing yourself. And we're going to really lean on you guys today. I wanted to maybe go really quickly into kind of what we're talking about, because I think people hear BDAs, DAS, ERRC. These are kind of these acronyms that people use. But really, kind of what are we solving for? We see it really primarily probably in education for our client base more than anything, but we see it in hospitality and healthcare among others as well. But really what it is the ability to boost in-building coverage for communication systems, at a high level. And I'm going to get Hilmi and Tracy to kind of dig into some examples, and for Hilmi to give us some detail on kind of what that means. But we see it a lot. The problems we're solving for is, in education, at least 50% of buildings have failed emergency responder radio coverage. What that means is they can't talk with the police or fire radios won't communicate in buildings, in all parts of buildings and schools. And in Texas, where most of our clients are, that's a requirement that is part of the Texas Education Code, not just to install these and make sure there's radio communication, but also to maintain those systems. And these things have changed rapidly. The funding environment has changed rapidly with schools. So we've seen this, a lot, and that's probably driven a lot of the growth we've seen. In hospitality and healthcare, it's a little bit of a different story. But poor cellular coverage in hospitality, there's some studies that indicate that for guests to not have in-building coverage for cell phone. If you can imagine, if you were to check into a hotel and not have cell phone coverage, what a frustration that would be, and what you would, could seriously consider maybe not coming back. 71% of hotel guests more likely to book with properties offering contactless check-in, meaning need to use their cell phone rather than having to go to the front desk and use the key card on your phone rather than an actual physical key card. And then in healthcare, there's a lot of serious medical errors linked to communication breakdowns. A hospital as busy as it is, as many people are as in them, I think they both need that emergency responder radio coverage, but also that cell. It's probably the cell is probably more important for them than maybe education, but we see this across all of these different verticals. But we'll dig into a couple of these examples shortly from where SEMA and Aerowave with Tracy and Hilmy have really seen this in the real world. But that's kind of the context of this. These are real costs that a lot of people don't realize they're bearing. And there's even state and local regulatory regulations that prevent or that force, for instance, schools to actually put in these BDAs. So we try to be forward thinking. We want you to be proactive rather than reactive to these things, and make sure that we're covering our bases and make sure that our clients are taken care of before they have a problem. So, Hilmy, if you wouldn't mind, maybe go through a little bit about, everybody hears these words BDA, DAS, ERRC. How do these things really work in kind of plain English?
So basically, as the construction advances, they use very technologically advanced material, even when they modify the existing buildings. And obviously, there's a lot of tax benefits for that too. They use better glass for heating and cooling insulation, and they use smarter other construction materials. These are great, but what they do is they block the signals coming from the towers. That includes cellular and public safety signals. So when you are modifying your building and building a new building, the probability of signals are going inside of that building is getting lower and lower. So therefore, when you go inside of a freshly built building, all of a sudden your radios or your cell phones start not working. But outside you have great signal. So there's a very simple solution. So what you do is you basically, since the signal outside is great, you attach an antenna on your roof to pick up the signal, and and that antenna is called roof antenna or donor antenna. That because donor means it's just picking up the signal from the roof, and then through the cabling you bring that signal down, but that's still pretty low. And then that donor antenna picks up the signal. You run the cable, and then you add an amplifier. So this amplifier amplifies the signal you take from the roof. And then you put smaller antennas inside and distribute that amplified signal. And basically, you're repeating whatever the signal is. It could be a public safety signal for the radios, or it could be a cell phone signal for your cell phones. You're basically bringing the signal using two important components. That the first one is where the signal meets at the donor antenna, which is at the roof, and then you bring the signal down using a cable to the amplifier, and then from there it is distributed. it's an amplifier basically, but we say bi-directional amplifier. Obviously, bi means two. So this amplifier, that means this amplifier is working two ways. It picks up the signal from the tower into your device, and it amplifies your device's signal when you're talking on your device using the indoor antennas going back into the amplifier, going into the donor antenna, and from the donor antenna, it goes to the tower. So the amplifier works two ways, transmit and receive. What you hear is receive, and what you send is transmit. So that's basically what it is. BDA is an amplifier that works in two ways, transmit and receive. And your donor antenna is at the roof, picks up the signal, and you have a few indoor antennas, depending on how big your building is. Those are the distributors. They could be in any shape, usually white, but they can be painted. That's basically what it is. These are very simple systems. Obviously, you have to install them according to the building code and the fire code if it's a public safety DAS. But basically the DAS is a neutral term. It's a distributed antenna system because you're distributing the signal into the antennas using different electronic components and the cable. So that's basically what it is. You know, you pick up the signal with one antenna at the roof, use an amplifier, amplify the signal, and the amplifier works in two ways. That's very as simple as I explain.
Got it. Well, thank you, Hilmi. And just to kind of follow up, one quick question there is that basically the same way the cellular signal works as well? Cellular boosting?
Absolutely. Because as you guys know, fire departments have towers, and cellular operators also have towers. So you're basically picking up the signal with an antenna at the roof and distributing it, no matter what the signal is. It could be anything. It could be any other signal too. It could be paging. It could be any wireless signal. Could work the same way.
Got it. Great. Well, thank you, Helmi. Moving on here, I'd like to have you, Helmi, kind of walk through what the process is that you see of actually installing a BDA from kind of before the installation happens, kind of what happens, and then all the way through to completion and acceptance by the client. So kind of if you could walk through kind of what the process is, you know, from the time that we find out there's an issue until we've resolved that issue, kind of what's at a high level, what's the process to resolve a BDA or to design and then install and accept the BDA?
Right. That's for public safety BDA on a existing structure, right?
Yes. Yes.
Yes. So it's very simple. Basically, we have meters, and we're certified to use them. You need 2 certifications for now, but fire departments are adding more, which I already got the next certification that they're going to require. It's a NICET certification. But for now, most fire departments are requiring 2 certifications. One, do you know how to use your meter certification? We have that. And then also, are you authorized to do these tests in the United States, which is the general radio operating license? We also have that. So when you have these 2 requirements, you are eligible to do these tests. So go inside of the school, and depending on the square footage of the school, we divide the school into 20 or 40 squares. If the square foot is very, very big, each floor, then we divide the school in 40 squares. If it's not very big, then we require, and then we do it 20 squares. Each square should be, if each square is bigger than 2,500 square feet, then we go into 40 squares. So basically, we take our meter, go to each square, and take a reading of the jurisdiction's control channel, which is just a frequency. Every jurisdiction has one or more control channels, and we get in touch with the fire department usually, and get that frequency and test it, and that is called grid test. And we do it on each floor, and there's a criteria that if the signal is weaker than a certain decibel, which is currently negative 95 dBm, if those numbers are smaller than negative 95 dBm, if you have two of the grids, two of the squares, that value lower than negative 95 dBm, then the floor fails. And what you see in that the picture on the left is a failed grid test. What this means is the police or a fireman walked on those corridors where it's red, they would have a hard time communicating with their radios. And if, God forbid, there's something happened in that area, then they wouldn't be able to talk. And when they can't talk, then they are not going to be working on their 100% potential. So that creates a danger when you're considering if this is a school, a lot of kids and workers, and if this is a hospital, you're looking at all the patients and stuff like that. That's a very risky environment, as you can see. So basically, when we have that, we send that to the customer and the fire department, and we put a design together to solve this problem. And that design package is called submittal package. It doesn't only include the design; it includes the materials that we use, because they must be met with the International Fire Code requirements, right? And then once we put a submittal package, we send it to the fire department for a permit. And there are reviewers at the fire departments, and they review our plans and the equipment that we're proposing to build. And once they approve it, we then contact with the correct person at the facility or the building, whatever that is. Then we coordinate to build. And once we build it, we do an initial test, which you can see on the picture on the right. And if the test is successful, we call the fire department inspectors. And once they come and test it with us, they give us a thumbs up and approval. And if we made any adjustments from the initial submittal, we basically modify that and send the final as-built document to the customer and the fire department, and that's how we close the project.
Got it. And then Tracy, if you could maybe talk a little bit about when we get called in, typically, is it, a client has discovered that they have a failed grid test, or how do they find out? How are we typically, learning from our clients that they have an issue? What is kind of that process has been like historically with our clients?
Yeah, sure. So sometimes we've been reactive and sometimes we're proactive. Some have been because they have a failed grid test already. Some have asked us to do the grid test. So we go in and do the grid test and show them pass fail. I have a lot, if you want me to go into like specific customers we've helped, I can do that because there's so many
just
different
like typically, you know,
scenarios.
because I think there's a broad, it seems like to me, there's a broad array of awareness of this issue from our client base. There's some that know this stuff that is coming, and then some of them find out like the day before a building is opening that they didn't get their certificate of occupancy. So like kind of typically, where are you seeing this stuff? How can our clients kind of maybe go from that reactive to proactive approach
So
to this?
some have called us, and the fire marshal has come in and where they failed, and they call us for a solution. I had a school district that they were about to move into the new school and find out they can't get their CO because they have areas that failed. So we literally went in and completed that, I think, in 2 weeks, just in the nick of time. And then, you know, like Hilmy kind of went through, we did the testing again, and they had a pass, and they were good and got their CO. So
Yeah, I think we do see that, you know, we've had some, it's not the first time. I can think of at least one other example where that's happened. And, you know, this is a regulatory issue that, you know, that that buildings won't get certificates of occupancy, even if it's not a new building, if it's a renovation of an existing building. We've seen that happen too. And so that's something that, you know,
they will
add,
they'll add storm shelters, and we'll have to go in and do it because they added a storm shelter and there's no service. I've had a school district where we did public safety, and then also they had no cell coverage. So we went in and added, kind of worked off that antenna system and added a cell BDA and helped their cell coverage also. And then another scenario I can think of is we did, I had a school, 0 cell coverage, and they had a rave mass notification system that didn't work because they had no cell coverage. And we went into the school and gave them cell coverage where they had none before, and it also helped their rave mass notification work with the amplified system.
I think this is the kind of the heat map of what we did with the cell on that. I skipped ahead a little bit on
I think that's actually a school, that they had rave, and they were, I mean, it was amazing the difference.
Yeah. And so, and just kind of fill in the guests here on kind of what rave is and how it works and why this was so important.
So it's a mass notification that's on your cell phone, and everybody has it. And if you have no cell coverage in and around the school, well, that mass notification isn't going to work. So these antennas, they boost the signal of all the carriers, AT&T, T-Mobile, Verizon. And once we did that, now they're able to use their cell phones in and around the school. So
and so they could get the alerts if something terrible would happen, then they need to be alerted. And this is sort of a heat map. Helmy, correct me if I'm wrong, that kind of shows the boosted signal, or what the predicted boosted signal would be once we put in the distributed antennas. Is that kind of what that pink circle is on this map?
Yes, those are the antennas in the center of the pink, but those colors shouldn't be very important unless they get to a dark blue. All the colors that you see, green and yellow and red and I guess purple in the very, very close to the antenna, all of them will provide adequate coverage. It's just that is actually for us engineers to see how strong the signal is. But every color you see in that property,
That's good.
Yes. I mean, for an end user, it could be. It should only be 2 colors. One is a pass color, and the other one is a fail color. And there is no fail color in this example.
And before, Tracy, this would have been all blue or gray, because they couldn't use their cell phones at all. And we see this.
Correct.
So I want to go back a little bit and talk about kind of how the combination of these two things, because we've talked about, I think, emergency responder radio coverage. We've talked a little bit now about cell. What's kind of the benefit of packaging this together? And, that's kind of a question for both of you. Maybe Tracy, you could take it from a kind of what the client's perspective is, and then Helmy, maybe you could talk through a little bit of the technical there.
Yeah, I mean, you can go ahead, Hilmy. There's a way to tie. So if you could say you have a public safety antenna system, you can kind of work off that existing system to boost cellular also.
Mm-hmm.
We've done that in some school districts here recently, and it's a cost savings. So, I mean, without going into a lot of detail, there's a couple ways you can go about a cellular BDA. You can do the expensive way where you involve the carrier equipment, but it's very time consuming and costly. And then there's just you're boosting the antenna system, not using the cellular carrier's equipment, and it's faster and less expensive. And that's what we've done in most cases, examples I have, and our clients are all really, really happy with the coverage increase.
Yeah. And Hilmy, just kind of very quickly here, I think we're getting close to time here. Just
Yes.
you can use some of the same infrastructure, is that right? Kind of, if you could enlighten us a little bit on that.
So basically, when there's a cell phone and public safety requirement in a building, what we do is we basically use two roof antennas, one for cellular and one for public safety. And we use two amplifiers, one for public safety and one for cellular. But we can reuse all the indoor antennas that I mentioned earlier as common, because the frequencies that we use for cellular are too far from the public safety frequencies. So there is basically no interference. So let's just say cellular frequency is a double bass in an orchestra, and the public safety frequency is like a mandolin. So it'll never interfere each other,
Mm-hmm.
right? When you see somebody playing a double bass, a big bass, and then the other person is playing mandolin, you'll never mix these two. It's the same thing basically.
Mm-hmm.
So we basically use two instruments, two antennas on the roof, and then but the indoor cable, all the cable that we run and all the antennas will work for both systems. So that's basically how we do this.
Got it. Thank you, Helmy.
There's one other thing I need to mention.
Sure.
This is basically what we do at SEMA Wireless, and therefore we have material at all times.
Mm-hmm.
So there is no the lead time, the cable is going to come in a month, or the amplifier is going to come in 2 months, or my antennas is coming in 3 weeks. No, we have everything. We have 3 or 4, actually 4 now, warehouses in Houston, Austin, and Dallas area. And we have immediate material available to start your job tomorrow. Mm-hmm. So we're not a company that do these things as they come. We do these every day. Yeah. So when other companies are buying cable by foot, we buy cable by mile. When other companies are buying connectors by 200, we buy them for 10,000. So we always have material to start your job tomorrow.
So, Helmy, you took the words out of my mouth.
My
question I was going to ask the two of y'all is, if I find that I failed a grid test, or if we've done a grid test together with SEMA and you failed, how long does it take to actually install one of these things?
Well, I mean, obviously, if your school is very small, we can finish in a few days. But I mean, if you're talking about a school that is in a 7-acre land, I mean, that's going to take a little bit more. I mean, because it depends on the square footage.
Yep.
But a regular school, we get it done in a week or two, maybe 3 weeks if it's a big high school.
And some of that is not just the work to actually install it. It's working with the fire marshal, getting the design signed off, all that kind of stuff
Yeah.
too.
Yes, I mean, we have very good relationship with many fire departments in Texas, and we personally know them. And sometimes they take their time for permitting, but many times they tell us, "Hey, I got your document. I don't have the time to fully review it, but I glanced at it. You can start working, and your permit will come later." We've done that too.
Yeah.
So many times we don't have to wait for permit. Sometimes we do, but many times we don't, because we know the fire marshals personally, and they just take a look at the submittal package that we send them, and they don't see anything wrong, but they don't have time to go deep into the document. They tell us by email or verbal. They say, "Hey, you can start, and if I see something not sitting, I'll let you know, and then you can modify it during the install if the customer is in a rush."
Got it.
We've done that many times, yeah.
Perfect. And this is why we like working with Hilmi and SEMA. This is why we've had such a great partnership with them. They're Hilmi and his team are technically brilliant. They have all the relationships, and the lead time is basically zero. And so this is why we've done dozens and dozens of buildings now. Tracy, just one last question. I know we're a little bit over time. This will be the last one. You've worked with a lot of different, types of clients. How are people paying for these things? Are there grant money available? Is it bonds? Is it, for an institution like maybe not a educational institution? How are they paying for it? What is how do they get comfortable buying these things?
Yep.
So kind of if you could walk through maybe the education side on one side and then the
Yep.
non-government
All
side.
of the above. This was just cellular, but we did a luxury hotel in Dallas. Of course, that's the owners paid for that out of operating money, and then now the owner has other buildings in Dallas. The hotel reason was, like you had mentioned earlier, for the hotel guests to increase their cellular coverage, but now they've got other buildings that they own, buildings that have different tenants that they want to help, that are renting out of their building, high rises in Dallas, for example, and they want those tenants to have better cell service. They have none, so they can't really run their business inside that office building because they have no cell service. So they're trying to help them out. So they're looking at doing that now. And then, so school districts, yeah, it's been bond money. It's been some Cycle 1 grant funds. Some have just taken it out of their own school budgets here and there.
And some of it's out of the construction budget if it's like a new building.
Some of it's new construction money. And there again, it depends if they're being reactive or proactive in the beginning. So yeah, just lots of different ways. There we have an ability to help through Motorola with grant writing for clients. So that's another service we can help provide. So
yeah. And we've seen, I think, recently a lot of Cycle 1 grant money, particularly. I know you can use it. We know you can use it for this stuff. And if, we talk to school districts all the time who have extra money, and if they, from Cycle 1 grant money, the Safe Cycle 1, and you can use it on BDAs. And, you should seriously think about it if you haven't, to keep, because it's something that I think is, it's something the state is really mandating. And I think they want to make sure that this in-building coverage stays good. So, well, thank you. I know we're out of time here. We're over time, but it's been a really, really great webinar. I've learned a lot, and I think hopefully our clients have too, and our guests here. Tracy and Helmi, thank you so much for your time. And I know you guys have a lot a lot of buildings to connect here. So we'll let y'all get back to it, and we'll be in touch shortly about the next webinar. I think we're going to do something on surveillance in the next couple of weeks. So thank you for everyone who came, and have a wonderful Friday and a good weekend. Thank you.
Thank you. Bye.
Goodbye.